Algebra 1, Lesson 10, Solving Basic Equations. Now let's get into the good stuff. In this lesson, we're going to start exploring equations. An equation is a mathematical statement that states that two expressions or values are equal to each other. For example, in a previous lesson, we mentioned that fractions can also be division problems. The fraction 12 over 4 is the same as 12 divided by 4. So we can write the fraction in an equivalent statement, defining it as being equal to the value of the division expression. We can write it as 12 over 4 equals 12 divided by 4. We can write equivalent statements like the previous one with any expression or value, if we know that they both have the same value on either side of the equation. For example, the square root of 4 equals 2, or 2 squared equals 4. The most important element of an equation that you must remember is that in the process of solving an equation, any operation you do on the left side of the equation must also be done on the right side, and vice versa. Otherwise, the mathematical statement will not be equal. Let's look at an example. Here we have an equation. The square root of 9 equals 3. If we add 2 to the square root of 9, we must also add 2 to 3 in order for the statement to be true. So, the square root of 9 plus 2 equals 3 plus 2. You could evaluate the right side of the equation, and it will be true because the value is equal to the left side of the equation. So we can rewrite this as the square root of 9 plus 2 equals 5. The same concept could be applied to subtraction as well. What a surprise. 2 cubed equals 8. 2 cubed minus 3 equals 8 minus 3. So, 2 cubed minus 3 equals 5. Now let's use this concept with variables. Take a shot at this. If 5 plus 3 equals x, what does x equal? If we evaluate 5 plus 3, then we'll get 8, which by definition must be the same value as the number on the right side of the equal sign. So, x equals 8. Let's take it a step further. 7 plus x equals 2. When we start doing these kinds of problems, it's always best to try to get x by itself on whatever side of the equation it is on. So, to get x by itself, you need to subtract 7 from the left side. But according to the math gods, you have to also subtract 7 from the right side. So now we get this. 7 plus x equals 2. Subtract 7 from both sides. Now we have x equals 2 minus 7, which equals minus 5. You probably saw this coming, but just like how we can use the plus and minus operators to help us solve equations, we could use multiplication and division to manipulate equations to solve for an unknown variable. Let's get right into our first example. Example 1. Solve the following equation for x. 7x equals 77. Like with all equations, we want to make sure we end up with two results at the end. We want both sides of the equation to be of equal value. We want one side of the equation to be just the variable by itself. So how can we manipulate this equation to get both results? Well, the way this equation is set up, we can see that in order to get the variable by itself on the left side, we would have to divide by 7, so that it cancels out with the 7 on the top and makes us have x by itself. And to make sure we follow the other important rule, we also have to divide the right side of the equation by 7, to make sure that both values are equal. So when we divide 7x by 7, we get x, and when we divide 77 by 7, we get 11. So our final result is x equals 11. Now you may have noticed that we started off with a division example instead of multiplication. It's because using multiplication to solve equations often involves working with fractions, and we all know how that makes a lot of people cringe. But if you know how to work with fractions, it won't be difficult to work those types of problems out. Let's look at an example. Example 2. Solve the following equation for x. 1/3 x equals 8. Now, one important rule to know when trying to use multiplication to solve these equations is the reciprocal rule. We use this rule to divide fractions by other fractions, but also use it to simplify equations with fractions as constants. So we multiply 1/3 by 3 over 1, which if we use the multiplication operation rule we learned in a previous lesson, we would get 3/3, which simplifies to 1 over 1, which is just 1. Remember, the x was still attached to the 1/3, which we got rid of by multiplying by the reciprocal. Getting rid of in math terms mean that we turned it into the number 1. So now we have 1 times x, which is just x on the left side of the equation. What do we do next? Is that a broken record I hear? Yes, we have to multiply the right side by that same reciprocal. Now remember, the reciprocal, 3 over 1, is the same as 3, so we basically have to multiply both sides by 3 to get the final answer. 8 times 3 equals 24, so the final answer is x equals 24. If you are trying to solve for an unknown value multiplied by a fraction, another simple rule to use is to multiply both sides of the equation by the denominator of that fraction. So in the last example, we could have just solved it by looking at the denominator 3 in the fraction and multiplying both sides of the equation by that number to get x equals 24 at the end. Use whatever rule you feel comfortable with. Now for the final challenge. All of our previous examples involved solving equations with 1 or 2 steps, but the reality is, you're going to need to solve equations using multiple steps as you advance further in math and science. The same rules still apply, but you will need to keep track of all your operations so that you follow the fundamental rule that an equation must always have equal value on both sides. Pause and solve the following equation. We will work it out on the next part. Final example. We have 2x plus 5 equals 7x plus 8. A good first step is to always try use basic operations to get the unknown variable on one side and the constant on the other. It is a personal habit of mine to start with the constants, but you can start however you want as long as you get x equals something at the end. So, I start off by subtracting 5 from the left side because I'm comfortable working left to right, and I can get the 2x by itself, which makes life easier. Since I chose to subtract 5 from the left side, I have to subtract 5 from the right side as well. So now we have 2x equals 7x plus 8 minus 5. Remember when we talked about variables and like terms? Constants are considered like terms, so we can combine them anytime we can to make our work easier. So we get 2x equals 7x plus 3. We still want to get an x equals something. So in order to do that, we have to subtract 7x from both sides to end up with minus 5x equals 3. Divide both sides by minus 5, and our final answer is x equals minus 3/5. In your academic career, you'll run into different types of equations that may be more complex than the ones in the previous examples, but the rules you use to solve them still remain the same. Just make sure both sides of the equation are equal, and make sure you get the unknown value by itself on either side. Mostly by convention, the unknown value will be on the left, but it doesn't always have to be the case. Hope we didn't lose you yet, because we aren't even halfway done yet. See you in the next lesson.